So I've just said any current larger than 15 milliamps will permanently damage the LED. And what most of you did was most of you found what voltage that would correspond to in the resistor. So I can work that out as well. So I'm using V equals IR, and I can find it's 15 milliamps. So 15 times 10 to the negative 3 gives me it in milliamps, or I can divide it by 1,000 to get what it is in amps. So converting the 15 milliamps to amps, so that would be 0.015 amps multiplied by 270, and I'll get a voltage. So if I do that calculation, so 15 times 10 to the negative 3 times 270 is 4.05 volts. But that is the voltage dropped across the resistor only. That's not the voltage from the power supply. So this is actually a high demand. This is a high demand question. Most people who got any marks for this got the first 2 marks, which was for correctly getting this. Lots of people did not spot that it's milliamps. So lots of people sort of did most of the correct working to get 2 marks, but then lost 1 mark because of the power of 10 error. So go back to the circuit, and with the power supplies providing the voltage across the LED and the voltage across the resistor. So the voltage across the resistor I have just found, so I could add this in, but I've just found that the voltage across the resistor is 4.05 volts. And what the power supply is doing, so if I just sketch this here, the power supply is providing the voltage across the LED and the resistor. So it's providing 4.05 volts, and then what is it providing here? Well, we can look at our graph, and our graph says that, or you can look at the table, when it's 15 milliamps, this 15 milliamp value, it's 0.6. So if the power supply is providing 4.05 volts here and 0.6 volts here, and they're in series, then the total voltage provided by the power supply is the sum of those 2 values. So the total voltage is 4.05. The voltage drops across the resistor plus the voltage drops across the LED. So we get 4.65 volts. So that's the maximum voltage of that power supply.